here we a little bit start. So we have all the time working with our system. Well, that's pretty nice. We having a Jira, we have a lot of tickets there. We are very motivated as a developers to fulfill the expectations. So we do this, but sometimes not all things are getting well, especially when we are very close in front of the production time and trying to even, not even production, I think based on my experience, I can even say refinement for the sprint. So and you're gonna show something to stakeholders and then you figure out, okay, nothing works together. So, or it works, but not exactly as expected. Or even stakeholders find really improbable behavior that cannot be called as a feature. So we start to figuring out what is going on, and in the past, as everything has been located as a one big system, so there has been kind of nice common let's say practice to add logs and kind of punishing our main running application by adding more logs in order to understand what is happening with the system. We added more and more until we find the root cause, and then what actually happens is, because with having the logs, they're getting to be the penalties to the system. That's sometimes people even right now I observing on my team, so they don't realize it, that having something in the main thread or in the child of the main thread will penalize your system, even when it is just a log. So what is happening then? You reduce your performance of the system, you increase the latency. So that means even when you sometimes do the fix on your system, as a Java is by the nature a concurrency environment, yeah, it will work just and it may happen. Or I observe when they remove the log, when they clean it up, they realize, okay, we are having the big latencies here, so they remove all these logs, and then it pop up some different kind of issues. Yeah, so it's like a never-ending story. It's still present, even those days, as I know that everyone wants to be on the hype and using the super cool technologies, but it's still there, yeah, and still the same behavior is observed. So what we're gonna talk more today is about what is observability, because I've been watching also a couple of videos in order to figure out how to go with this topic, and yes, it's in somehow, and I have been reading also a lot of blogs and posts about this. What does observability actually mean? To make a system observable, it's kind of logical what it means. Okay, I get some measurement data of it. Okay, we're gonna touch it. We're gonna touch the difference between the monitoring and profiling and what kind of value it brings to us. We, of course, microservices. Everyone wants to have a microservices right here and right now, and what we can observe where, and we try to build some system and we try to observe it here right now. We try to run the system and collect some data and figure out whether we are able to find what is happening here and to increase our understanding of the system. So, what is observability? Okay, so this is, I think, well, I would say, what means having an observable system. So that means I can measure some data. I can kind of get some data out of it. In case of data points, I can do some graphs or charts which gives me some insights on the system what I'm dealing with. For example, where I'm experiencing very big latencies and where. Also, this was kind of what has been kind of puzzled me when I'm reading these blogs and observability, and this is more than monitoring or more than profiling, and this is some kind of ability to dynamically change your queries actually that you create the charts, of course, because you have a data points. For me as observability, just collecting the data points to have this ability, and based on the data points, of course, you create some common metrics. Of you create some, for example, you would love to have some logical stuff like how big is my heap, or what are my latencies on particular APIs, and you can aggregate this data. So, and those blocks are something, oh, observability is more than just creating a metrics. And then when I read this through, okay, so actually at the end, you would love to create something what you can observe, right? You can see, and the best thing is you basically create the metrics. It doesn't matter if you have something kind of statics, like a common one that are obvious, or you kind of playing at the kind of real time with the queries. So still you have a data and data points that you can kind of form in some kind of output. This is for me the observability. And yes, each kind of if you are following the pattern, and even if you run on premise, so each system have a different telemetry. Doesn't matter which kind of technology is used. It has a very different behavior, and each system, each point of you should do the different assumption of it, how it should behaves. But this means you should think on it. Well, recommend it. You cannot kind of generalize the similar behavior. So what we can observe, like of course hardware, containers, endpoint, even the libraries behaviors, if you are doing the updates of the libraries to ensure that the system is behaving similarly. And here it leads me to kind of highlight the differences between the monitoring and profiling. Monitoring is more about getting those measurements, getting those metrics, and getting the alerts. I think right now these days a very, very cool alerting system can be Prometheus, or you can add the Grafana here, which is difference between the Prometheus and Grafana is Prometheus is simply for collecting the data points and so on, and it doesn't allow you to kind of do the more sophisticated aggregation and display them in the dashboards as Grafana does, which you can export the data, use the Prometheus as a data source for those data points, and then create a nice dashboard, which Grafana offers a lot of plugins how you can aggregate, how you can do the statistics, and so on, and to kind of visualize the data in the way you want. So this is why they are connected together. Profiling, at least. So if you have monitoring, it's worthwhile to have monitoring, yeah, because this will be probably the first signal. Okay, if you have defined the thresholds, for example, what is acceptable for you to take on particular endpoint, the request response times, and so on, or what is acceptable heap size that you can have, or something like that. If you have defined these thresholds, then you can set the alarms here, and you can of course you can even in Grafana to add some kind of additional logs. You can add here by using a log key and define another alarms here to be informed. So actually Grafana provides you the more features than the Prometheus itself, which is really like a data point focus stuff for collecting. Profiling, according if you have these alerts and so on, and you find out that there is a particular problem, so profiling, you are kind of get more granular samples of the data, like a more detailed view here. It costs more, I think, than just sharing some kind of logs or data points here, because you cannot. The point is, if you would profile everything all the time, right? You can generate a couple of gigabytes of the data. If you have, okay, it doesn't. For example, if you have like one service, yeah, and you will send one data point per the request. That's cool. But what is gonna happen is, and you will say it each second, yeah, from some time, from some stuff. So it's very nice if you have one, but if you have a million requests and you will do all this for a million requests, you can imagine how much data you need to go through and who will analyze it. I know that we are investing a lot of money to kind of develop artificial intelligence parsing or some in order to understand the data. Yeah, but anyway, this kind of amount of data that you are able to generate will be, I think, not too much for IE, but well, would make a sense because someone needs to pay anyway for the storages, for the transfer, and so on. So I mean, well, in many cases it's not sensible, and you can profile when you have the alert. You go and just put some kind of acceptable time frame and check it out what is happening here. So here, well, we trying to with the microservices go to from many years right now. I know everyone is repeating this, like getting to microservice patterns. Like right now, we separate each of them to a very single purpose system. We create many microservices. Then the companies have 100 services, which most of them they don't know what is happening with them and why they are here. Someone forgets, okay, cool. And even when you know what is happening, especially right now, you need to observe data. You need to collect them to ensure that they are all stable and running as expected. But this is exactly what is here is, okay, so here on the chart, we have 4 services. Okay, one is getting bigger, let's split it. Okay, you split it into the 3 different services, and maybe it looks better for the manager. Oh, we have right now 3 instead of 1. Okay, but how you validate your hypothesis that right now the situation is better? How are you gonna measure this? Like, how? Like just saying, I don't think that it's enough. So this is the response of the community is exactly this observability and the monitoring and measuring and even the profiling here. That you can, okay, here I have, it's way better. We just achieve better latencies, and latencies are less because of this. And because of this, I gotta touch later. So we have this streaming pattern. Basically, most of the application are getting to be distributed these days. So if you think about, as we are here right now, JVM developers, the way how what we can observe is coming actually from the technology we are working on. And we know that the JDK, the Java Development Kit, contains the Java runtime environment, right? And the Java runtime environment contains the Java virtual machine, and Java virtual machine have some parts here. And aside of class loading, when you start your application, and there are a couple of class orders built on the hierarchy, yeah, that they loading the classes like from internal libraries, then they get your main project, load and create, fulfill the additional like a method area which is created at the start time. So you see here the answer what we should observe and how and where we should pay attention is coming from the basic ground of the technology what we are working on. So okay, so we would love to measure the heap. Heap is a place where anything the instances of the object, basically the classes, are reside, and here is running the garbage collection algorithm, which is kind of cleaning stuff we don't need, right? And on this heap, since the Java 8, there we have also the metaspace here. Before there was a per gem, so you've been maybe later before experiencing which kind of out of memory issues because now there was too small place, so you spent some time to set it up before. But right now it's a part of the heap, so you can unload the class on a fly and load it in, and it will be the information garbage collected. And there is a stack area. Stack area it's a very interesting area because it's created per the thread. And as I mentioned it before at the beginning, so the JVM is a multi-threaded by the nature. So there are many threads running on the background, even when you have the main thread, right? There are like more than 10 threads, and definitely the threads, they are running as a daemons. Daemon means the thread which is ended when the JVM is ended. So that means even then, you see, we go back to the observability, because when we end the JVM, the virtual machine, and someone, for example, have forgotten to set the threads as a daemon, right? They will keep running in the background until they finish their job. And so, so you see here, it means, of course, if you kill the containers and so on, this is different. But if you are running some other stuff somewhere and they are just keep running in the cycle, this job, it will consume your resources. Yeah. So again, we need to observe this behavior. So anyway, the stack area created per thread, it has it actually has the methods references that is executed now. It's pop up at the top on the stack, right? When it's finished, it's getting out. When it's this is called the stack frame, that you can have the complete free of which kind of method has been on the bottom executed, or which kind of have been processed till the end. And okay, this is one part which is per thread, and then we have a native stack area. And here this is a tricky stuff, because there with the stack area, it's using through the GNI, the native interface, it goes to the operating system. What is nice on the Java is that actually that we have a heap, we have an object, we have these execution engine. Yeah, we have a bytecode, right? It's translated. But what is happening with the bytecode is that at the runtime, it's dynamically compiled by the JIT compiler to the application instruction, and this behavior is probably used as identified as a VORA, write once, run everywhere. But actually here you need to have a specific implementation of the JVM which is running on the system. So it's true, but with the limits. So here, see, the JIT compiler is actually dynamically compile the bytecode into the computer system instruction, and it can optimize. Yeah, and here, if you are, for example, having kind of messy code, or I don't know, let's say not very structured code, a JIT compiler will be forced to optimize it. So in order to achieve the good performance only because of your code, you need to run your application on the server for a certain amount of time. And if it is bad, not very suboptimal code, it can take a long time. But on this time frame where you don't have your optimized code kind of a little bit, so you will pay you can calculate it in the money. Yeah, so I think it makes sense to use design patterns or any kind of make your code cleaner. Yeah, then you can reduce your cost, especially, for example, in heap allocation, when you have the very known example with autoboxing, which can happen anytime. Yeah, not only because but because of a library, you can allocate more heap, like a bigger, and then you can, of course, you can calculate more money. So anyway, program counter here is per thread. It's a counter of the instruction which is right now executed. And you see here, everything is here connected. So everything this can we observe. And this is where we can observe everything. Based on my experience on here, we are developers, and of course we have JUnit tests, and some of us are using test containers in order to run the test against the Docker. Some of us run the Docker Compose application in order to generate some load and to ensure that some points working together. That's cool. So all this technology went, but there are still many projects they just use the unit test and a lot of mocks there, which are basically then giving no offense here, but although you finished your ticket on the Jira is good, but if you connect all these together, you may very often get to the not nice surprises. Of course, and this is a funny thing, you have, aside of Docker Compose, where you can create your small services, you can run it up, and right now we have very powered systems, so basically you can have up to, I don't know, you can have on your laptop 64 gigabytes of RAM. Yes, so right now, so we are facing some interesting surprises in my presentation. So, okay, so you have enough resources most of the time to run these things and test it. So, and to collect the data points and shift them into your, you can import your dashboards or whatever and create some metrics. You can, of course, parse the log. This is the one what you can observe, logs, and traces. So here, what is the traces are, this is, one of you mentioned the Jagger or Zipkin. Yes, the traces are amazing, right? They are from the web application. They are able to identify exactly the flow through your root or of the microservices and see all the endpoints that are present in this trace. Okay, they can give you some kind of idea of what is happening with each particular request and how they are there. But maybe there is a one point what can we improve on the traces. I will touch it. Here, what I want to do, the traces are kind of, there's a span, right? They have kind of time frame from where the particular request have from where it begins, where it ends, and then it's go bottom here to the tree. Okay, you spend here this time on API, you get the authentication, you get to the database, you maybe just authenticate, you get to this endpoint, you are using a multiple databases, and then you can in a span, I think, also to get some what had been happening here in the database, which kind of data you get back, and so on. So yeah, of course, it's just individual requests, and you can just then aggregate some collections of those requests, and in order to get from I would say from the top perspective, the view what is actually how your application behave. But this is on the surface. So it doesn't still tell you anything. You need to connect with this surface, you need to connect with logs or with the metrics, what is happening. And this is what we did, for example, when I've been trying to contribute to Open Tracing project, which is right now, I found it kind of few days ago, part of, as I mean, part of Open Telemetry project, which is also the collection of APIs and SDKs, which kind of frameworks how you can observe again the system. So, and here I put here nice example what I did, just an example we present on one conferences where you create the three endpoints that they communicate together. You see here on the trace, which is the span of the trace, which is a GET request, how it goes till the database, and how they are these red points. These red points, what we did, we just put into the span the ID, right? Each span has an ID. It's very unique ID, and what we did more, we sent the event in this case to the fly recorder, and the fly recorder gets this ID, and you see here on the bottom, by knowing this ID, I can, when I do profiling, yeah, I can then just take a look and then complete threads. I'll show you, yeah, and have complete over picture what has been really happening wrong. For example, there has been cycle, or there has been unnecessary iteration, or there has been autoboxing. So you see here, I get from the surface, which is for me the trace here, I identified there is something taking too much time here, and I go completely bottom on into the JVM and get the information here by the profiling and figure out what has been wrong with this. And of course, in this example, there has been simply thread sleep. It's suspended thread and it has been waiting certain minutes, and this is why it is here those two span. And in this spans are these two very long time, like half a seconds. So, but you get a point how I get from the surface to the bottom. And here, what we have built on here will be, I have what I have seen on those presentations about observability. Everyone has been talking, but no one has been saying. But a lot of you have been saying, showing some examples. So in this process, I did a little bit coding, which I want to present to you. I have a Prometheus and Grafana, which I think a Prometheus is getting very big part of the market and collecting this point, similar to how to say, I have forgotten, micrometer. Okay, micrometer, which is used to collect the counters and Gaug, right, in order to get the measurements from the Java that we're gonna use. Grafana, of course, it's used, I think. Do you use something different than Grafana aside of Dynatrace or Datadog or something like interface? No, I don't think so. Me neither. So this is what you can do. What I did here also, I can create a Postman collection, right? And you can in Postman, just when you don't have any kind of load, you can generate and repeat the sequence more in order to get the load. So, but okay, that's nice. But I just use the Gitling here because Gitling is very cool, and it's great to create some order and also some order sequence of the events that should happen each request. For example, okay, I have logged in here successfully, I have filled out the form, or I have put here this thing, no, I have reached API, I get the response, I use the data from the response and fill out this and connect other response. So I can kind of do the data flow in the load, or like, I don't know how to say it. So data-oriented flow, load, data-oriented load. So, and what I can do is also use the fly recorder to get the data. That's what I'm gonna do. So in this case, we use the Java, Kotlin, and Scala. I used, I don't know, like most of you, as I ask, use the Spring Boot, but I see also a lot of people are using the Quarkus here. So what I will have, as I said, you can have a Docker registry, you can use Docker Compose, but most of people are right now deploying to the Kubernetes. Yeah, it can be the OpenShift or Kubernetes cluster at the Amazon. So this is what I can do. And we generate some load. So let's run it up. So I have created everything into the script. So you see here, because I have created a script to building my Docker images, to push it into the local Docker registry, which I downloaded, and it's running there. So I have used the Kubernetes, the local one. So I check whether some other pods are running. So here, get pods. There is running already Grafana and Prometheus here. The reason why it's already running, because I already imported the boards I have created here. By the way, this project will be then published on our OpenValue Git repository, so you can check it out. So and try to play with it, because the reason is I can compare. Actually, this is nice. I can compare different kind of behavior on the responses across the frameworks I have here, and I have put here into the project some most popular frameworks I think, or we think, or that some research diagnosed there as a Micronaut. It's not Ktor, which is more than Kotlin. In Kotlin, way popular. There's a Quarkus and Spring Boot. So, okay, so let's run it. I will deploy here. Yes, you can see I have here the Quarkus. I hope you can see here. So I will deploy the Quarkus ones, or not. I would love to deploy them. So let's deploy them. So they are probably here. So let's, yes, they are here. And you see, you have all these possibilities on your local computer when you can do all the stuff. So it's very hard only to start. Okay, so let's take a look. Oh, what is happening? It's okay. So this is not what I want to see. That's by the way. Okay, let's go here. So I have here the monitoring, Quarkus and Java. So you see my endpoints are up here, but if I can show you last 3 minutes, you see I have been already playing with this. So this is why I have it. So I've been just trying to say it. So right now we have it up back again. So you can use the measurements here, you can use the alerting here, and so on. Nothing. The Grafana gives you so many nice features, and I have forgotten. So let's make some load, right? This is not that much fun. So as I mentioned, then in Gitling, it's not hard. Yeah, even when you are the Java developers, they have a nice flow to create some simulation. It's basically all described there based on my experience. You don't have to have much. You can even, for example, in this case, I'm sharing the common libraries and common model which I use on the application, and I have imported here to my Gitling project. That will be also published there. And then I have created the simulation here. And here you see I have post and check. What is happening here? I get the post here. I get what I have post, and I verify whether it's properly stored by the checking. So it's kind of flow. You can do whatever you want with it. So you can ramp the user. I ramp the user 2000. But as you can see, aside of it, the Gitling allows you to put everything into the command line using, of course, Maven. You can add the properties and run there as a separate project here, and you can add it into your pipeline. So what I've been doing, so you can just really customize this framework in a way that you can put into pipeline, and this load will be happening. For example, we did it in a GitLab. So it has been built on the fly and so on. So it was very helpful to ensure that about our stability of the system by the small load. Okay, so let's run it. So you see here are happening something already. So here we got some load here, and what? Oh, what? Which one? Okay. You mean like this? Okay. So there is something happening each per minute. So you see it's getting high. So I don't know why the time responses are not happening, but they come. They come again. So okay, we wait a bit. What is nice here, as I told you, by knowing the understanding what is happening with these heaps, and so with a heap, you can create just a really simple garbage JVM, GC or a page, and you can take a look what is happening, and you can see that I have increased the pressure on my heap around 20% here. So, and you see some kind of Nice. This is where the monitoring may get some really tricky. Yeah? You can see some kind of so places. It depends how often you receive the endpoints. Yeah, because the situation may look like this, or completely different. Yeah. So this is why the alerting, when you're doing the monitoring, the alerting takes a place because like okay, ensure you okay, man, here's getting something wrong because this what I can see here may not really be relevant to the reality what we can record. So I have here the bots. Okay, I will check it out again. And as I said, what you can do here, you can go into your very isolated environment, and you can take a look here. And how many of you know okay, I have here the simplest script which is creating right now that I will profile my application for around 2 minutes and I will create a new recording. What is great on the both I have a I will Quarkus Java. Okay, so right now recording started. So it's kind of initiating the recording here, and maybe Java platform provides you also many kind of very neat libraries or utils. Better, many of you knows JCMD, right? Or is it something new? No, right? JCMD. This is very cool program because it allows you to connect to the Java process, right? Which you can verify a lot of other stuff like VM version which is running here, and you can see this is Java 17 here, which I can use for my just I don't know 18 or whatever other version here. And what is also is but you can ensure what is happening with your recordings. You just run, it's still running. Okay, cool. So I will wait until here.
Could you increase this size? Because I think that for the viewers at home it's might be visible.
Okay, no, I'm sorry. Okay, so sorry, I'm not ready to increase maybe my fonts. I try. Wait a sec, I get idea. Here, change. So maybe here I can go to 20. I don't know whether it works, you know. No. Okay, so the command can right now definitely when I check now still recording is running. So what I can there is increasing the here. So we can go here and check the monitoring of our Quarkus system. You see here, for example, if I a little bit you can see how much we can play here. What is happening here is this is a Java. I'm just curious why this not showing the heap committed from the Kotlin, because I have Quarkus Kotlin and Quarkus Java. Okay, but anyway, here it's definitely showing 2 responses. There are no, so we can here kind of add the new one. Sorry for that. Yes, you see guys. Oh, here there is a Quarkus. Oh, Spring Boot. Okay, so there is not Quarkus monitoring. So you see what you can do with Grafana, which is not very easy to do with how to say Prometheus, which is not ready for this. So right now I have apply. So right now I see the different behavior of the Kotlin. This is the Java. Yeah, how we use a heap. There is definitely something happening, and Kotlin is really different, really behaving differently, right? So it's, but although they have the same problem, yeah, it's auto boxing. So Kotlin simply increase the heap size like this, like a jump. But on the bottom, it will still show in very detail with more granularity that there is happening stuff, but you don't see it. But you see it just a jump here. And in Java, it simply shows some random points, but this is what will be happening. So that's what is happening. So here you see already some kind of GC allocation promotion rate. So right now it's over. So party is over. CPU is getting a little bit down. So this is all what you can learn about your system by observing. So let's put the stuff what we have measured here. I will ensure whether it's not running anymore. Yes, it's done. So let's ensure stuff here. You can here see that I have recorded stuff. And sorry. And I have basically here you can use the different kind of you mount your storage, right? Here I simply mounted from the Kubernetes to my local storage, but it can be S3, doesn't matter. The location doesn't matter, right? It's simply the storage system here. So, but you can already train it here. You can simply replace the link. You can use the environment properties to build. You can use our technologies to define the proper links to your storage system. But you see, here it's almost the behavior getting experience with cloud environment in your local system. Okay, so let's review it here. Let's run it out. So let's here. You can see here what has been happening here. You see here, but okay. Before, let's go to the presentation because I've continued. Okay, so right now what I have done right now is that I run the system, right? Some kind of application independently in the Kubernetes. Here I have for the presentation purposes. Okay, I'm gonna run the Java one and how to say Kotlin Kotlin one to see the diversity of the languages. That's what we did in a Quarkus environment. So what I can do more here, and what I want to show here is we can go here. And let's undeploy this guy. Yeah, let's keep Grafana stuff. I have forgotten the command, and let's deploy the other ones here. Let's more stuff here. So this is what is amazing, what I really do like. So right now I deploy more. So when I go to Grafana here, okay, it's the gun, but here I can import a different, oh yes, save the dashboards. Okay, so right now let's see here who is going to be up there. Yeah, Quarkus. It seems that it's a bit lazy here. That's not up, although it's up. So Quarkus Kotlin, but I have forgotten what I have actually deployed there, but it should be up, some of them. So, but you can do this on a fly basically, and have the class your experience. So here that we already said that I'm using a micrometer here in order to get the data point after the JVM through the Prometheus, which is collecting all the data points, and I'm using the Prometheus as a resource for the data points to display those on those metrics on nice charts. But I also show you how we can on the fly modify kind of nicely the experience, the chart. And where we are right now is we get some data. We created the event on here, and we collect the data we profile the application by using a Javafly recorder. And we found out that this kind of application is, for example, wrong, something is happening here. So what I can do here is I can zoom this section. I know I don't still know. Okay, so I have a section and I can go take a look on the threads here, what is actually happening here, and I can identify here on my flame view. And as I oh, maybe right now it's getting okay. Yeah, it's, I have resized, I shouldn't do this. So I have right now, so right now what I'm displayed, the Javafly recorder allows you to not only this kind of display the stack frames. This is what I even mentioned, what is happening, that the function goes on pop and you can get the stack frame from the JVM here and display them, but it allows the Javafly recorder provides you the possibility to parse all those stack frame and put them into the flame diagram, so that you can see the kind of towers. And what is more interesting is, okay, maybe I need to run them again. Okay, I will run. What is very interesting in what we have done there in Javafly recorder, you can highlight by the knowing a package the particular parts in these towers in the flame view. So I will show you again. So it crashes from whatever reason. It has been running very long time, and I'm using the development version. So, but let's put there some recordings. I can hear what I have here is a different recording. So right now it's, yeah, what is not optimal is that it holds all the memory stuff here. So let's take a look how it behaves. So okay, here we have the time frame. So let's select the selection, you see, and here we can go to the threads and see them, what they have here. This is the executor thread, and we can filter by the main. Oh, we need to find the good one here, and we can verify whether here you OpenValue, whether we have here in this thread. You see how many. What is interesting is, for example, Spring Boot initiate way less threads at the beginning than the Quarkus. Quarkus, from my point, I would say, in order to how to say, satisfy the workload, yeah. So it initiates so many threads. It's like a JVM on steroids, but it is helpful until you have something which comes from the I/O operation, because I/O operation can break all these kind of tactics and gives you the penalties. Or when you make a locks in the threads, then they got stuck. Yeah, so it's nice, but it has some limits where it is not nice anymore, that it initiates more threads. In this case, aside of it, you see what you can have here is a kind of different kind of behavior of the garbage collections here. Because what is important, what you should take out of this garbage collection, auto-boxing, it's fine, it's no problem, until it's causing the big pauses, because sometimes someone needs to clean it, the stuff, the heap, right? And if you have the big data here, the big objects that needs to be garbage collected, it causes the bigger pauses, and you can easily go to pauses which can maybe take a minute, yeah, and that delays. So those delays will be noticeable by your application. So here, why I put here this is Javafly recorder is running like a sidecar from here. It gives you very few penalties to your application. This is why this profiling is kind of very helpful, and you don't have to worry even when you profile the production system here. And the funny thing, it's push the events there. I will not have a time to touch it, but you can create, but you can find it on the web easily. It gives use the local thread buffers, which are very less price, and it transfer the data into the global buffers, and they are then stored in the repository. The issue here is that those repositories are just local. So of course you can use the streaming APIs, which is there implemented in order to push out the events there somewhere, but this is more again for monitoring purposes than for the profiling. So, but the micrometer, actually they use the same technique, kind of same approach, which use the same bar. He creates a repository where you put the counters and Gauke, but it's staying kind of and a different threads of your application, but it's still started from the main thread, so you get the more penalties than from here. But it's the most efficient tool, probably, this is now on the market, how you can share the data points. So right now it's something happening again. So here, right now, I have no screen. And right now you can see that here heaps can really resize very big, yeah, by simply this kind of behavior, and it can go there are like a half second, yeah, but it can really turn into be couple of seconds that it can be noticeable. And although there are couple of small pauses here, but the summary of the pauses at the end you will be surprised how many minutes it takes of the day that your system has been paused. From 20, it can happen that from 24 hours the system went up, 1 hour has been paused because of garbage collection. So it makes a sense to see it, to monitor your system and having the ability to profile it. And right now it's way easier when we are getting into cloud and Dockerized, containerized environment and virtualized environment than has been before. And even before it was easier, but only a few people did it. So this is probably all from my presentation. We will share the presentation here. I have give you some links what you can do this. I have keep publishing the articles on the FUJ about the new Java features and about the evolution of the JVM and Java itself. And the funny thing is, if I think back through, everything is sometimes somehow connected with observability. So everything, in order to understand, you cannot avoid this. You need to understand to the system. And from my personal experience is that understanding how the JVM works, which kind of parts has in execution environment, and the memory, what is the memory model guaranteed, gives you kind of very great hits what you actually should observe, instead of just writing some kind of queries and doing some charts which are nice. Of course, each chart is nice, which is visual, but it helps you to give a meaning to those charts and maybe just do the less and get more. Okay. Thank you very much for your time, for your listening. And if you have any question or you can share your experience with your system, yeah, feel free.
Oh, thanks, Miro. Well, actually, there came some questions via the chat, but first, the audience here, are any questions here? Yeah, please.
So at the beginning, you mentioned that logging or monitoring in general can cause performance penalties and so on. So what are your experiences in measuring the performance penalties caused by
Okay.
logging?
Okay, it depends on the kind of logs you have. Yeah, so if you have a lot of logs, as I said, this is running on the main thread, right? So every instruction you put into the main thread, it will be executed. So this automatically goes of the penalty. And if you put into the logging some kind of, I saw some put even the request to the service there and output, which has been connected with the database, right? So come on. So what will be happening? So of course you don't see it here, but if you profile by the I found it because I profiled the system by the Javafly recorder, and I saw the readings and I think, where is it happening with this causing the so much time that is spent because I allocate the event. So okay, I'll show you something what I thought that I will not have time, but you asked the question, so you get it. So how find it out? Something is happening with my screen still, but it's not because of me. Yeah, hey, even the IntelliJ right now crash. It's caused the crashes. So, but nevertheless, I allocate. I create an event, which I put the events across this some part of code. Yeah, this is what I said. There are the penalties of using a Javafly recorder, but it's not mine. I just replace the classes, or you can do the agents what we have. So you can add the agent, which then will be just bytecode modification and create the events according to special methods here. And it's a very okay. I don't know what is happening here, but it's not. I'm not a god. It's not my ability. So here is a simple event. Okay, element. Oh, I don't have it here. Okay. So okay, I go to presentation. There's something is wrong here. Okay. So here I wanted to show here. I create here event, and you can start the event in the here in the code. Just you instance the event and the start and then the commit here the event, and this code goes to the buffer, and then it's shared, and then I can here and I can track the event. I say I will check whether I have one event here, which is here. Oh no, this. But anyway, it will be displayed here, and I can create here the event and check it out what was been happening. I can filter by the event. Can only go here, create the exact here, and then I go back here to the threads and trying to look up where it's blocking or what has been happening here and how the memory has been allocated and where. So yeah, so this is basically, I found that there has been a lot of places which has been suboptimal instead of looking to the code. So JFark leads you to a root of codes very fastly, and you don't have to go through the hundreds lines of code or even thousands. Yeah, so that's my experience. I'm using a GFR in order to diagnose this most of the time. Yeah.
Another question from the chat. So a real life scenario. Sometimes a sub-process of a third-party library silently stucks or goes into an infinity loop. And the one asking the question is curious about the best practices to debug such a behavior or such a case.
Okay. Oh, this is amazing. So best practice is, okay, again, I'm not promoting a Javafly recorder, yeah? So,
why not?
but the best practice is really do the simple reading. And for example, what I showed you here is on the chat. Maybe I hope you see it. Yeah. So we have here the pods, and if I go to the pod here, I need to go here. Oh, come on. Okay, I'm in a pod here. No. Oh, I need to connect to the pod. I can connect to the pod, and as I said, the Java provides you very neat JMCD util, where you can start your GFR reading, and you can go 5 minutes of your GFR reading. Yeah, I am right now in a pod, so JCMD, I already show it, so I have here one running process, so I will connect it, and I can start the reading here. Yeah, so okay, basically I have here, okay, I had here, when it start blinking, I have here the command I wanted to show you. It's here. So what it does, because I love instead of repeating myself, I'm writing a script here. So I have here the start. You can start the duration. You can select the stuff. You can change the name. You can choose the setting profile. Yeah, because it gives you the more information from the GFR. You can parse, and I'm pretty sure that you will find out who is hanging there. It will be very obvious. So that's my best experience here.
Okay, thanks. Another question by Bert-Jan Schrijver. I'm curious about differences in the memory characteristics between Java and Kotlin. To my understanding, Kotlin code compiles to Java bytecode and runs in the same JVM and uses the same garbage collector. Yeah. So how does this lead to different memory characteristics?
Oh, that's important. That's I'm trying to find out. This is good, nice. Thank you for this question. So anyway, so what is seems to have, although they use the same JVM, right? I don't. Wait a second. Okay, I will add more stuff from the Kotlin that we see something. So although it's used the same JVM, so what is actually JVM? So there is a bytecode. It should produce a similar bytecode, right? The bytecode is then translated dynamically to the machine instructions, right? So there are 1,000 roads to Rome. So I don't know what is. I need to say I have a limited knowledge about the compiler of the Kotlin. Yeah, what I can see here. Well, I can only describe what I can see. So in this case, there is a running Kotlin code, and the Kotlin code is using the Java library, which has an issue, and it causes some pauses here. And although I know that this behavior has not been observed when I use completely Kotlin framework like a Ktor, yeah, it has been not visible here. The reason can be that the Kotlin compiler doesn't put the events there, so it actually does not collect much information, because what has been happening at the end is when I took a look on the pauses, yeah, in many cases the Ktor, although it's a complete pure Kotlin stuff, has been worse with the throughput as with the Java. So I don't know what is happening there. I see the memory allocation has been increasing, yeah, but I don't have I cannot answer this question properly. I've been trying to investigate it also, how Kotlin allocates it, but due to lack of time, I didn't put much more effort to do this. But Java is putting more internal event and doing more characteristic than the Kotlin thing.
Okay, so please promise that as soon as you find out, you write an article about it on our blog.
Oh, okay. I already did actually, but not exactly about this. I wrote the article about this, that actually, although the Kotlin does not show that it's happening, the garbage collection, it needs to create it's create a lot of garbage here. Yeah, it has been not shown. It has been causing longer delays in the throughput by allocating the memory than the Java. So, but without more explanation. That was only observation I don't know more details.
Okay, thanks. Any more questions?
I have a quick one regarding tracing the error and exception. So in regular way, I print the logs, I add some meaningful messages, then add the stack trace, right?
Yes.
With Javafly recorder, how does it look like? Is it like all the threads throw exception there, or?
No.
Could you please repeat the question so everybody at home?
Okay. How log looks? If I didn't understand, correct me, please. How does look exception in a Javafly recorder?
Yeah, correct.
Because you are used to print the exception into the logs.
Yes, stack
Okay.
trace, yeah.
So, and the stack traces into the logs. Okay. So, how it looks? There are, for example, exception field. You can take a look how it looks and who has been responsible, and you can, if you can of course take a look on the stack trace, which is not available in this moment, which is very interesting. So, but you can go from top till the end what has been actually happening here, and you see the stack trace can be here. We have it parsed, so it's it's kind of nicer display than you can print into the command line, because I can go to different leaves. So
You missed the line numbers, or?
yeah. Oh well, if you use, there is a okay. There is a plugin to the Eclipse, so you can use the plugin into the Eclipse to GR4, and it can lead you even to the line of the code if you have it get into Eclipse. So you can just do the transfer, but in many cases it's not. I'm not Eclipse user. I am using Eclipse only for OpenJDK development, not for application. Okay. Yeah.
Thank you. Any more questions? Well, if not, then round of applause for Miro.
And use Fly Recorder, it's for free.